Good day, sir. We are the Group 9 and the members of Group 9, Sabeliano Jerome, Solon Justin, Timagos Hans Lawrence, and Tipa Egypta. So, course Mtec 102, period semifinal week 1, session 1. And the topic is radar plotting. And learning outcome, students are being able to familiarize the terms and demonstrate the radar plotting. So, what is radar plotting? So, radar plotting is the graphic displaying of an encounter between observer on ship and one or more other vessel targets, and within radar range of each other. Plotting will be done on radar plotting sheet or on reflection plotter made or plastic glass. Primarily, it's done to determine if the risk of collision exists. Secondly is where it is found that such risk exists. It is used in an effort to determine the proper and sensible action which could be taken to avoid casualties. So here, the radar motion display. So the actual or true motion is expressed in terms of direction and rate of movement speed relative to the Earth. So as you can see in this image, that the true vectors of shift R and the true vectors of shift M. So as you observe here, we have the R1, R2, R3, R4 to R5, and M1 to M5. So these are the intervals of every 6 minutes. So every 6 minutes nag-change siya sa iyang vectors. So next is the relative motion are also expressed in terms of direction and rate. So movement of one moving vehicle to another object that after being or either stationary or moving is the combined effect of apparent result of viewing one moving vehicle against to another object. And subsequently, we estimate that apparent speed and direction of other pedestrians or vehicle direction of relative motion and relative motion, and adjust our own true direction and actual rate of travel to avoid collision. So here, the relative motion between two of ships. So we have the A1, which has a bearing of 180 to until 134 to 104. So muna siya sa in different intervals rate gyapon 6 minutes every 6 minutes nag-change siya nag-change ang bearing of distance. Also in the ships 1, the B1, the B3 bearing and distance. So next, motion of ship B relative to ship A and motion of ship A relative to ship B. So as you can see here the B1 and A1 is relative to each other. So it's also diagonally, and in the actual heading of ship B, so this is the actual heading of ship B. So nagkuan siya yang course is between 95 true. So one is relative vectors or rate and direction of movement of ship M relative to ship R. So this is the image of the relative vectors, relative velocity vectors. And kinds of plotting. So one is manual plotting, is done manually. So next is two main subdivision. So A, transfer plotting. So radar information are transferred to a maneuvering board sheet or rather plotting sheet. And B, direct plotting done right on a special plastic or glass surface over the PPI, provided the radar set has a reflection plotter using trace or pencil to construct the plot. So money siya ang maneuvering board. This is the maneuvering board, and the other is the radar plotting sheet. And this is the radar transfer plotting sheet. So the next reporter is Solon Justin.
So automatic plotting is accomplished by self-acting digital data processing equipment which is interfaced with the radar and provides audible and visual threat detection, graphic displays or plot, and readouts of the parameters of the problems, such as CPA, contacts true course, contacts actual speed. Two major parts. Automated system use computers to process the raw data. Image retention system use either high persistence cathode ray tubes or electronic devices such as video recorders and playbacks. These systems have the capacity to retain past positions of contacts. Next slide, please. So as you can see in the visual in figure 60, the logarithmic times. Look at the logarithmic time, speed and distance scale showing proper use of dividers and the names given divider legs. The time, speed, and distance scale is based on the equation distance times speed. And to remember this easily, we could use the triangle where the distance is above and speed and time is under it. So if you're looking for the distance, it is simply speed times time. And if you're looking for the speed, it's distance divided by time. And if you're looking for the time, it is distance divided by speed. Mastery of this scale is essential if it is to be used for solving time, speed, and distance. So in the compass divider, it shows the computation of the distance by using its scale. Next slide, please. Own course, true course. The speed of own course of own ship, OS. It is also noted. E, point of the region of the own ship, Victor, and target Victor, R. Target ship's first observation, initial position of the contact. This is pointed by the true bearing, range, and time of observation. If relative bearing is taken, change to true bearing. Next slide, please. M, target ship designation. Target's true bearing, range, and time. The end of target's relative motion on the first vector triangle. The end of the true target's course vector triangle. RML, relative motion line. Line connecting to RM. This is the target's relative motion in relative to own ship. This is not true course of target. DRM, target of the relative motion line, always in the direction of R to M, can be founded by transferring the RML to the center of the corresponding degrees. So for example, we have the circle, we have the radar, and this is the RML, and the point of the radar is in here. So simply just move the line to the center. So that is the DRM. So next slide, please. Closest point of approach. The point where the target will be at the nearest distance to the own ship. Bearing of the CPA is the true bearing when the target is at CPA. This is the perpendicular to the RML from the center. This can be computed by adding or subtracting 90 degrees to the DRML. The CPA, or time of the closest point of approach, and CPA, new closest point of approach. This is desired distance the own ship wants to clear the target. SRM, related speed of the target. Not her actual speed. This is the rate or speed at which contact close to the own ship. SM, actual target's true speed. This can be computed by measuring the scale, the magnitude or length of the vector to M, and apply the time and interval between R to M. CM, true course of the target. This found by transferring the E to M to the center of the center and reading the corresponding degree on her direction. Next slide, please. NRML, new relative motion line. After deciding on the desired new closest point of approach, or the NCPA, or the radius of the desired danger circle, draw a line, the point of execution, MX, tangent to the NCPA, MX, so it is known as point of execution. Next slide, please. Additional Victor triangle. After establishing the ERM, Victor triangle, and deciding the point of execution, MX, also desired passing distance of target, NCPA. Draw the NRML and own ship will decide the course of the action to take and method to be employed of the collision avoidance. For this solution, additional triangle vector diagram is plotted as follows. ER1M, Victor triangle. ER1 shows direction and speed of own ship to avoid collision. Transfer the line to the center will show the corresponding true course of own ship. R1M shows the new relative direction and speed of the target ship. Transfer the line to the center to show the corresponding degrees for the direction of an RML. AC, collision avoidance course. AS, collision avoidance speed. ROCS, resume own ship course and speed. Next slide, please. Next slide, please. Victor triangle diagram. Speed vector and speed triangle. The speed vector. Can you please go on the previous page? The speed vector and pictures of motion taking place. They have two properties. direction of motions, and speed of motion. So next slide, please. The vector diagram is made of 6 factors. First, OC, direction of E to R, OS, length from E to R, CM, direction from E to M, SM, length from E to M, DRM, direction from R to M, SRM, length from R to M. And you can see it on the diagram on the picture. So next slide, please. Target angle, or tan, is a relative bearing measured from CM and clockwise direction to TBO, or true bearing of ownership as observed from the target vessel. 0 to 360 degrees formula. Tan equals TBO minus CM. Next slide, please. TAS, or target aspect. It is a relative bearing measured from CM to TBO, either port or starboard. 0 to 180 degrees, target aspect is red. If TBO is on the port side of the contact, target aspect is green. TBO is on starboard side of the contact. Next slide, please. Rule for getting the target or the TAS. If tan is less than 180 degrees, then TAS has equal to tan, is equal to tan, naming it green. If tan is more than 80 degrees, 180 degrees, then TAS is equal to 360 minus tan, naming it red. So for continuation, here is the identified.
So for the continuation. So good day, I'm Deca Detibait. I am here for the continuation of our report. So this is an example of how to get tan. For example, of we have here TBO is equals to 214 and CM is minus to 270 plus 360. So equals 574 minus 270. So tan is equals to 304 degrees relative. And how to get TAS? So the formula to get TAS is TAS is equals to 360 minus tan, which is 304, is equals to 0.056 degrees. So TAS is, so since it is 360, so TAS is red. So TAS is equals to red 0.56 degrees. Next slide, please. Next slide, please. So we have here collision avoidance methods. Method 1 is equals to change course, maintain speed. While method 2 is equals to maintain course and change speed also. Method 3 is equals to simultaneous alternation of course and speed. So we have here the procedures of how to avoid collision. First is to determine time of collision, which is also called this as TCPA. Second is determine vessel's status in accordance with the international rules of the road. Next is call the captain. Execute transfer plan to make document on the situation. Plan when to execute the maneuver 4 to 6 minutes. And lastly, establish passing distance or NCPA. So we have here special cases, no Victor triangle form. So first, ERM. So ERM is what we call the on ship course, same as target ship, but target ship is faster than on ship. Speed and direction of relative movement is equal to that of on ship. EMR is on ship course, same as target, but on ship is speed is faster. Relative movement direction is opposite to that of on ship. MER is on ship and target ship same, but in opposite course. Relative speed on ship plus target speed, but direction is opposite to that of on ship. ERM is on ship is stationary while target is moving relative speed and directions equals target course and speed. ERM or MER is on ship moving while target is stationary. Relative speed of target is same as that of on ship but in opposite direction. RE to M is on ship is moving at same course and speed as target. Relative motion is 0 or NIL target will appear fixed on PPI of own ship. ME and R is own ship and target are both stationary and therefore relative motion is NIL. Next slide, please. So we have a classification of radar contact. In a risk of collision situation, the true or compass direction of relative movement must be changed. Simple rules for rapid prediction of the change in the compass direction of the DRM of a radar contact resulting from a course of speed changed by own shape can be invaluable, particularly in the multiple contact situation. The rules can be used only when using a stabilizer relative motion display. Next slide, please. So through brief inspection of the DRMs of several contacts on the radarscope with respect to the direction of the heading flash, a contact can be classified as being up the scope. If its relative motion is in the same direction as the heading flash, it is down the scope. And if its relative motion is in the opposite direction, we call it across the scope. If its relative motion is at right angle to the heading flash. Next slide, please.
So to continue, next slide please. So rules for course change. So the rules provide predictions of how a contact's relative plot and DRM will change as a result of a course change by own shift to the right. If the course change is to the left, the opposite effect can be predicted, valid irrespective of the position of contact and range of bearing. Next slide please. So up the scope, it is a relative plot will curve to its left when on shift turns to the right. Down the scope, it is a relative plot will curve to its right when on shift turns right. So across the scope, it will affect on the DRM until the contact classification is changed to either up or down to the scope contact. Next slide please. Next slide. So the rules provide prediction of how a contact's relative motion changes. The speed changed by on shift. So reduced speed, it is a relative plot move up the scope when on shift reduces speed or stop. Increased speed, the relative plot moves down the scope when on shift increases speed. Next slide. Next slide please. Application. When the contact is faster than the on shift, the effect of its on shift evasive action on the compass direction of relative movement is generally less than and it would be on shift where the faster shift note that the contact is always faster than the on shift in the up the scope and across the scope cases in making maneuvering decision using the DRM technique. Speed information on the ratio basis is adequate. The observer need only to know whether the contact speed is about 1/2, 3/4, or twice on shift speed. So next slide please. So as you can see in the diagram, up the scope. So it is stated that up the scope is to the right, and as you can see, the RML is pointing to the right, and M and R and E is 00200 Rs and 0000 Rs. So next slide, please. Next is down the scope. So it is going down the RML. So next slide, please. Across the scope. So it is crossing to the both left and right. Next slide, please. So reduce the speed. So as you can see, it is reducing the speed on its left side where it goes. So next slide, please. Stop. So it is the same, but it has a 00. It has a 00 knots. Next slide, please. So increase in speed. So as you can see, increase in speed, as you can see, it is moving on its right by increasing its knots. So next slide, please. Time Victor minutes rule to find the speed and distance. 6 minutes rule. Speed and this speed equals distance times 10. Distance equals speed divide 10. 10 minutes rule is speed equals distance times 6, and distance equals speed divide 6. So 12 minutes rule is speed equals distance times 5. Distance equals speed divide 5. And 15 minutes rule is speed equals distance times 4, and distance equals speed divide 4. 20 minutes rule is speed equals distance times 3. Distance equals speed divide 3. 30 minutes rule is speed equals distance times 2. Distance equals speed divide 2. Next slide, please. So rule 7, risk of collision. Paragraph A, every vessel shall use all available means appropriate to prevailing circumstances and conditions to determine its risk of collision exists. If there is any doubt, such as risk shall be deemed to exist. Paragraph B, proper use shall be made of radar equipment if fitted and operational, including long-range scanning, to obtain early warning of collision and radar plotting or equivalent systematic observation of detective objects. Next slide, please. So paragraph C, assumption shall not be made on the basis of scanty information, especially scanty radar information. Paragraph D, in determining if risk of collision exists, the following considerations shall be among those taken into account. Subparagraph 1, such risk shall be deemed to exist if the compass bearing of an approaching vessel does not appreciably change. Subparagraph 2, such risk may sometimes exist when an applicable bearing change is evident, particularly when approaching a very large vessel or tow, or when approaching a vessel at close range. Next slide, please. Rule 8, action to avoid collision. Paragraph A, any action taken to avoid collision shall, if the circumstances of the cases admit, be positive, make an ample time, and with due regard to the observance of good seamanship. Paragraph B, any alteration of course and or speed to avoid collision shall, if the circumstances of the case admit, be large enough to readily apparent to the another vessel observing visually or by radar. A succession of small alteration or course and or speed should be avoided. Next slide, please. Previous So paragraph C, if there is sufficient sea room, alteration of course alone may be all the most effective action to avoid a close quarter situation provided that is made in a good time, substantial, and does not result in other close quarter situation. Paragraph D, action to avoid collision with another vessel such as result in passing the situation. So to continue the report, paragraph D, action to avoid collision with another vessel shall, such as a result in passing a safe distance. The effectiveness of action shall be carefully checked until the vessel is finally passed and clear. Paragraph B, if necessary to avoid collision or allow more time to assess the situation, a vessel shall slacken her speed or take all the way off by stopping or revising her means of propulsion. So next slide, please. Lookout zone. So lookout zone, the assessment zone, action zone, and danger zone. It must be an assessment zone 8 to 12 miles. An action zone must be 4 to 8 miles. And the danger zone must be 4 miles. So what do we determine the assessment zone? The CPI, or closest point of approach, and the TCPA, or time of closest point of approach. CM and SM, status of vessel in accordance with Call Regs 72. So that is the end of the report of Group 9. Thank you.